Hi guys, welcome to today's A-level session. Today we are going to be looking at a question taken from paper 1 in June 2018, and the question is based around differentiation and stationary points. It was question 2 in the paper and we're going to go through it today. So the first part is saying a curve C has equation y is x squared minus 2x minus 24 to the square root of x, where x is greater than 0. Find dy dx. So all we need to do is differentiate our equation. Now when we differentiate, we do the power times the coefficient and then we lower the power by 1. So in this case there is no coefficient, so it's just taken to be 1. So we've got 2 times 1, which gives me 2 x, and then I'm going to lower the power by 1, which just leaves me with x to the power of 1, which can just be written as x. So next term, I'm going to do x to the power of 1 times minus 2. So 1 times minus 2 just gives me minus 2. And then I'm going to lower the power again by 1, which gives me x to the power of 0. So anything to the power of 0 is just 1. So this can just be written as 2. Now this very last one, we have to change this into something with an indice, so something with a power. So this can be written as minus 24 x to the power 1/2. Just put in my minus there. So over here we're going to do 1/2 times minus 24, which gives me minus 12, and then x 1/2 minus 1 gives me minus 1/2. So I can just put that in as my new power. Okay, and that's the first part done. So now d2y dx squared, you just want to differentiate this equation again. So 2 times to the power over here, which is 1, gives me 2 still, and then lower the power by 1, which gives me 0. Anything to the power of 0 is just 1, so we can leave that as 2. Now this next bit doesn't have an x term in it, so I can totally discard it from my equation now because I'm differentiating y with respect to anything that has an x in. If it doesn't have an x in, I don't even need to consider it. Next term, I'm going to do minus 12 times minus 1/2, which gives me plus, because 2 negatives make a positive, so plus 6 x minus 1/2 minus 1 gives me minus 3/2. And that will be the first part done. So verify that C has a stationary point when x is equal to 4. So when x is equal to 4, when we think about our stationary point, if we've got a curve, might look something like this. Now our stationary point is the point at the top where the gradient is equal to 0. This implies there is no gradient basically at this top stationary point over there. Okay, and there shouldn't be because it should be a flat point on that curve. So if we want to verify that it has a stationary point when x equals 4, all we need to do is substitute in 4. And verify that the gradient is equal to 0. So I'm just going to draw a little arrow and I'm going to continue that down here. So if I have x is equal to 4, I'm going to put it into my first derivative, sorry. The reason I put it into my first derivative is because I know when I differentiate an equation, I get the gradient. So dy dx should be equal to 0. So I'm going to have 2, substitute in 4, minus 2, minus 12, 4 to the power minus 1/2. So 2 times 4 gives me 8, minus 2, minus 12. Now because this is a negative power, it's going to be over 4 to the power 1/2, which can just be written as square root of 4. So 8 minus 2 gives me 6, minus 12/2. 12/2 is also equal to 6, so 6 minus 6 equals 0. Therefore, stationary point at x equals to 4. So next part is we want to determine the nature of this stationary point and give a reason for your answer. So we know that when we're trying to find the nature of a stationary point, we can sub it in to d2y dx squared. Now when we sub in our x value, if we get a value greater than 0, then it is a minimum. If we get a value less than 0, it is a maximum. And if we get a value that is equal to 0, it is a point of inflection, we call this. So we need to sub in our x value, so what's the nature of the stationary point at x equals 4, into d2y dx squared. So we get dy dx squared is equal to 2 plus 6 bracket 4 minus 3 over 2. Now this will give us 2 plus 6 over 4 squared and then cubed. Okay, so this is going to give us, when we work that out, is 2 plus 6 over 4 cubed is 64, square root it gives me 8. So 2 plus 6 over 8, I'm going to continue down here, gives me 2.75 or 2 3/4. This is greater than 0, therefore this point is a minimum. So according to our working here, therefore min. Okay, and that is all we need to do for that question. I hope you found this useful, guys. Thank you.